This is the video for homework 10, question 2. From the lecture notes, pages 1 to 50, collect the definition of properties of stochastic processes. The list of 8 properties. The first one is the White-Sands stationary, or WSS. A real stochastic process is White-Sands stationary if, first, its expected value is a constant, and the second, its autocorrelation depends on T1 minus T2 only. White-Sands stationary property can be determined with only a constant expectation and autocorrelation relate to only T1 minus T2. And obviously, White-Sands stationary does not imply strict Sands stationary. The second is independent increment process. It means that xt1 minus xt2 and xt3 minus xt4 are independent if t1 minus t2 and t3 minus t4 don't overlap. The Poisson process, the random walk, and the Wiener process are all independent increment processes. Third property is the Markov process. Yeah, the Markov process. A process xt is a Markov process if the past has no influence on the statistics of the future under the condition that the present is known. That is, for any n and t1 to tn decreasing order, we have this. The probability that xt1 is smaller than x1 under the conditions of t2 to tn equals this conditional probability. Poisson process, Poisson impulses, semi-random telegraph, random walk, and Wiener process are all Markov processes. The future state of a Markov process is determined only with the present state. That is, all Markov processes are memoryless. A normal process is a process xt is normal if the random variables xt1, xt2, blah blah blah, xtn are jointly normal for any n t1, t2 to tn. That is, it has this density function. Joint density function is like this, where the x underline is a vector of x, the big X underline is the vector of xt's, the eta underline is the expectation of x underline, and c is the expectation of x underline minus eta underlined times x underline minus eta underline transpose. The statistics of a normal process can be determined in terms of its means, eta t, and autocorrelation are t1, t2. And eta t is a function of t. That's this. A strict Sands stationary. A process is strict Sands stationary if its statistics does not change when shifted on the time axis. That is to say, a strict Sands stationary property implies that this equality. Note that the t's are all shifted with the same amount, and the value is all the same. A White-Sands stationary process is not necessarily an SSS, but an SSS is a WSS. So it goes this way instead of that way, instead of backwards. It cannot go backwards. White noises. VT is called a white noise if the autocorrelation is in form of QT1 delta T1 minus T2. This is corresponding to the first question. It is always assumed that white noises have zero means, i.e., that is to say, the expectation is zero. the mean ergodic process. Xt is a mean ergodic process if this limit, the limit of t to infinity, 1 over 2 times t, integral from minus t to t, xt dt, is the expectation of xt equals the expectation of xt in a mean square sense. And number 8 is the last one, the martingale. A stochastic process is said to be martingale if the expectation of xt under the condition of xs equal to x1 for s smaller than t, the expectation equals to x1. That is to say the expectation of a conditional probability equals the condition itself. And we also know that one random walk and the Wiener process are both martingale.